Hi, everyone. Thanks for coming to this talk, bringing GitOps into the GitOps, bringing OCI into the GitOps world. My name is Jesse. I am co-founder and CTO of Akuity and co-creator of the Argo and Kargo project. Today, we'll be exploring how OCI, which was originally built for containers, is now becoming a universal distribution format for all kinds of cloud-native artifacts, and what that means for GitOps. So first, a brief history of OCI. So as you probably know, Docker was the company that popularized containers. But when Containerizer was taking off, it was a proprietary ecosystem. And every platform had its own way of packaging and running containers. And so it was a bit of a wild, wild west. So in 2015, the industry got together to create the Open Container Initiative. And its goal was about making Docker images portable and consistent across runtimes so that the same image could run anywhere. And OCI standardized 3 core specs. The image spec, which is how a container is packaged, the runtime spec, and how to actually run that image, and the distribution spec. And this is how we push and pull artifacts via registries. And these 3 things gave us a foundation for container delivery. So fast forward to today, OCI isn't just about containers anymore. We're now using registries to distribute things like Helm charts, Wasm modules, Lambda functions, policy bundles, and even machine learning models these days. So anything that can be described as a package can be stored and versioned as OCI artifacts. So this opened up new opportunities for GitOps. With OCI, we can now start deploying from OCI registries instead of Git. We can promote immutable versions across your environments. And we can support offline and edge clusters where Git cloning from Git isn't ideal. So let's walk through a couple of these scenarios. So one place where OCI really shines is with their disconnected environments. So with GitOps, the Git server is typically running from some centralized location. But that Git server might not be accessible in air-gapped clusters that aren't connected to the internet. So instead of trying to sync from Git servers, you can move OCI artifacts even through like USB drives and load them into your private registry in your air-gapped cluster. So it's the same delivery workflow, just now air-gapped. Another use case is if you have edge or network-constrained locations. So at the edge, Git pulls can be expensive or slow. And meanwhile, OCI registries support things like caching and mirroring natively. And this makes distribution much more efficient. So if you think about content delivery networks, it's the same idea, except we're now extending this to configuration. And if you need things like performance and redundancy, using things like registry mirrors, caching layers, makes OCI distribution fast, scalable, and redundant. So you might already be practicing registry mirroring through some of the features in the cloud providers' artifact repositories. But you're probably not mirroring your Git repository. So these are another benefit of OCI-based deployments. But there are going to be some trade-offs between using Git and OCI. And so let's compare how they might trade off when considering versioning, packaging, security, delivery, and collaboration. So for versioning and change history, Git is fantastic for human-readable history. So you can look at commits, diffs, PRs, annotations. With Git, every commit is actually a version that could potentially be deployed. With OCI manifests, they go through a release process. You have to produce a new image and you tag it. But its focus is on immutability. So every artifact is content addressed. OCI, you don't have a native way of diffing two artifacts or understanding the history between two artifacts. Git is great for auditability. You can see the commit author, messages, timestamps, down to the individual lines of a single file. With OCI, you're only inspecting manifests at a specific tag or digest. With artifact composition, so Git, when you're just dropping human-readable files in a directory in Git. OCI, you are bundling everything as this one immutable package. And this actually ensures that what you deploy is exactly what was built every time. When you update an environment using Git, you're making these small incremental changes via Git commits. And OCI, you're pushing a new artifact to an artifact repository. And when it comes to reproducibility, Git is, depending on what you practice, Git is less reproducible. So you're probably having your Argo CD app run Helm template or customized build. And most people don't practice this technique called rendering manifest pattern where you render it out to branch. So it means that your manifest can change if you maybe upgrade Helm or if you upgrade Kustomize. On the other hand, with OCI, what you should be doing is fully rendering out your YAML so that during the build process, so that your artifact contains the final rendered or hydrated YAML. And this ensures that everything is immutable and predictable when you actually come to deploy it. With security and provenance, both OCI and Git, they have strong integrity models. So with Git, you have your commit SHAs, and OCI, you have digest. But the biggest difference is with provenance. So Git can tell you who's changed the source, but OCI can carry things like attestations, SBOMs, and signed provenance data that shows how and also where an artifact was built. In terms of access control, Git providers like GitHub give you very robust apples on things like Git repos, branches, and even down to a path and with code owner files. OCI is much more limited. Most of the apples are based on the repository level. And in delivery and performance, this is really where OCI excels. With Git, you're cloning the whole repository, every branch history. But OCI, it pulls only what it needs, a very specific digest or tag. So in general, OCI is faster, cacheable, easier to mirror if you want to redundancy or for air-gapped use cases. And when it comes to collaboration, Git is still the winner. So you have PRs, approval, diffs, branches, reviews. OCI doesn't have any features like that. You just push things to the artifact repository. The review process has to happen before you actually do the build of that artifact. Git lends itself to things like experimentation. You can try out new manifests with a branch and forks. But with OCI, the only way you can do that is to, again, push a new artifact and then deploy it. And in terms of readability, Git is great because you can just visit the commit and see directly the YAML that's in that commit. With OCI, to figure that out, you have to download that artifact and unpack it and see what's inside. And as I mentioned, OCI adds this additional build process to your pipeline, which with Git, as soon as you commit that YAML change, is immediately applied by your GitOps tool. OK, so let's now start looking at how you might implement deploying from OCI artifacts. Before I do that, let's walk through what the current workflow that you're probably practicing. So what most people do is you have a Git repository, and you have a user or a machine, doesn't matter, and that thing makes a change in your YAML with the new Git commit. And then you have your GitOps tool, whether that's Argo or Flux, is watching this Git repo. Normally, you're watching like the main branch or head, and then it detects that there's a new Git commit, and then it, in the case of Argo, it'll run Helm template and then apply those manifests to the cluster. Let's see how this might look like in OCI. So this is one workflow where it kind of mimics what you're already doing with Git. In this case, you have your human or machine committing or pushing Kubernetes YAML to Git. But now you have this build process where this CI step packages those manifests, and that's what runs Helm template, and then it pushes to OCI repository. And then your GitOps tool, like Argo or Flux, will monitor the tag, a consistent tag like latest, and it notices that latest, the digest for latest changed the meaning. So I went from SHA-1234 to SHA-3456. And then when that happens, then it applies those manifests to the cluster. But if you're practicing this, it still means you're not fully immutable. So just like you shouldn't ever run container with tag :latest in a cluster, I would recommend against running images with mutable tags. So another workflow is to go fully immutable. And so the first couple steps are similar. So you're going to first commit and change the KTML to Git. CI is going to produce a new OCI image. It's going to produce a second image, version 2 of that image. But you need something to pull the repository to know that it's there's something new in order to figure out the digest and set that digest on the application spec of Argo. So you can use any automation system. We build a tool called Kargo that can do this. But basically, Kargo would notice that there is a second image. And then what it does is it sets the application's desired revision to the SHA, the digest. So it's not, Argo never watches :latest. It watches, it's updated to a very specific SHA. And then Argo can then apply the manifest from that digest that it derived, or not that it derived, that Kargo set in its spec. OK, and this last thing is just so you understand how you might publish a OCI artifact of YAML. And it's really simple. So in this directory, you can organize your manifests on how you see fit. So in this case, I just have 3 environment directories, so dev, staging, and prod. And then you can use a tool. There's any number of tools. Auras is the popular one for just basic pushing to OCI. So just like a Docker push, instead of Docker push, you could say Aura's push. And then if you want, you can also update the tag, the latest to point to that new version. If you're using Flux, Flux has its own CLI that essentially does something similar to this. So Flux has, I think, Flux artifact push. But it's basically the same thing. OK, so I'll just go ahead and show a demo of what you might do this as like in automation as a GitHub action. If you want to follow along, you can visit this example. OK, let me walk through the GitOps repository. So this is the application, Argo applet. And so the thing that is different is we now have, it's not much different if you think about it. Really, the repo URL is now OCI URL. And then target revision, it can be a OCI tag, or it can be a SHA. Like this is, if you want to go fully immutable, you would set a SHA in your target revision. Otherwise, you can have Argo keep checking if the latest tag got updated. So this is the app. Right now, my app is synced to latest, and we're going to go ahead and make a change and build and push a new OCI image. So I'll go ahead and just change a pod annotation. OK, that should kick off a, oh no, then I'm going to release, sorry. So and then I'll show you what the GitHub action is going to do after I kick this off. All right, so basically my GitHub action is it's going to do that same set of steps that I did in the presentation, the Aura's push. So it's not that, it's pretty simple. I have those env directories, and all I'm doing is running Helm template, basically, and then storing in a directory, and I'm or is pushing that directory into GitHub container registry. And so now if I look at my container registry, you see that I have a new image tag 008. And if I refresh this app, Argo should detect that my latest tag, it changed meaning. So now that SHA is out of sync from it was synced to a previous SHA, and then now it wants to go to this other SHA. And if you look at the diff, you can see it should have the change that I made. OK, so that is the style of workflow if you kind of want to mimic what you're probably already practicing with your Git tool syncing from a branch or even a Git tag. But let's see how you might go fully immutable. So I mentioned there was, you can use tools like Kargo that can update the application spec with the SHA. Kargo is one tool. You can use CI. So Kargo has OCI support, and it can detect new images pushed to OCI registry. So I pushed that 008. So let me just detect that in Kargo. OK, so we do see that 008. But since I want to go to a specific SHA, and it's already at 008, I'm going to go back to 007. And what I have Kargo doing, all it's doing is this single update, which is updating the SHA of my Argo app. And you can see that now if I look at this app, what it did was it changed the target revision and set it to something explicit. So that was the all Kargo was doing. It was just a single thing that was updating target revision. So that's the second workflow that you can do if you want to go fully immutable. So there's no, the only thing that is, actually there's nothing. The latest tag is not even considered in this style of workflow. All right. Okay, so when you might want to use one or over the other. So if you have a need to continue like doing collaboration, you have a need for like readability, you update things very incrementally, and you don't want to introduce like a new process into your workflow. And you depend on Git for like the viewing and auditability. You can stick with Git. But you might have these hard requirements for air-gapped networks or offline, or you want the performance and redundancy benefits. That's really where I would recommend using OCI. So we help customers, for example, that their locations are on satellite networks or even airplanes. And so for those customers, I think they would really benefit from having an OCI in that location to store the package, keep all their manifests in case they can't reach the Git server. Other use cases with supply chain metadata. I didn't touch on this too much, but it's possible for a Git tool to refuse to deploy OCI artifacts if they aren't signed properly. So Flux already has this feature. And Argo, which only recently introduced this OCI support, can't yet verify OCI artifacts. But if that is a requirement, then you would also need OCI. Although you also can achieve something similar with both Flux with Argo and using GPG keys. Both of these tools have features to make sure that signed commits are deployed. Okay, so yeah, OCI and GitOps, I think it represents a new phase of evolution that combines both the best of source control and artifact distribution. I think this space is going to evolve pretty interestingly over the next couple of years. I'll take any questions.
Yeah, I had a question that when you did your demonstration, the application you're deploying used an OCI, but the Argo application itself was still in a Git repository, right?
Oh, yeah. It was, yes.
So, I mean, you can't, how do you do OCI all the way to the top?
Oh, I see. OK, so I just happened to store the app spec in Git, but I wasn't practicing like an app of apps, if that's what you're.
Yeah.
Yeah. So if you were doing app of apps, so you committed an app spec in Git, and that one, now you have a problem of updating the target revision in Git itself, right? Yeah, you're also going to need tools or something to help. Instead of updating this app spec, the live application spec directly, which is what you saw in the demo, that could have instead made a Git commit to the Git repo with that SHA. And then app of app reconciliation or syncing could have eventually applied that to the cluster. So instead of updating the live object, it could have committed to Git and to the same effect.
Okay.
All right, I'll do a hallway track. If anyone has any questions, I'll stick around. Thank you.